Imagine a world without computers. No smartphones, no internet, no video games. Now, what if I told you the blueprint for the modern computer was actually drawn up nearly 2 centuries ago, not with silicon chips, but with brass gears and steam power? It's a story of genius, ambition, and a machine so far ahead of its time, it was almost lost to history. This is the incredible tale of Charles Babbage and his mechanical computer, the machine that almost was. Let's journey back to 19th century London, a time of steam engines and industrial revolution. In this era of invention lived a man named Charles Babbage. He wasn't just any inventor. He was a brilliant mathematician, a philosopher, an engineer, and a true visionary. Babbage was frustrated by something that plagued scientists and navigators of his day: human error. Mathematical tables, essential for everything from engineering to sailing, were calculated by hand. And humans, well, we make mistakes. A single misplaced digit could lead to costly, even disastrous consequences. Babbage was obsessed with finding a better way. He famously declared, "I wish to God these calculations had been executed by steam." And so he set out to build a machine that could think with numbers. His first grand project was the difference engine. Picture a colossal mechanical calculator weighing several tons and made of thousands of precisely engineered parts. Its purpose was specific but revolutionary: to automatically calculate polynomial functions and print the results, eliminating human error entirely. The British government, seeing the potential for creating flawless navigation tables for its Royal Navy, was impressed. They funded Babbage's ambitious project, and he spent years perfecting his design, pushing the boundaries of what was mechanically possible. A small section of the engine was successfully built and it worked perfectly, a testament to his genius. It could calculate faster and more accurately than any human computer of the day. But Babbage was a perfectionist, constantly refining and improving his designs, which led to delays and escalating costs. The full machine, however, was never completed in his lifetime. Why? Well, we'll get to that. Because while working on the difference engine, Babbage had an even more profound idea. He envisioned something far beyond a simple calculator. He imagined a machine that was unlimited to one specific task but could be programmed to solve any analytical problem. He called it the analytical engine. This was the true leap, the conceptual birth of the general-purpose computer. It had all the essential components of a modern computer, just in mechanical form. There was the mill, which was the central processing unit or CPU, where the calculations happened. And there was the store, which was the memory, where data and intermediate results were held. It was a stunningly modern architecture. How would you program this mechanical brain? With punched cards, an idea Babbage borrowed from the Jacquard loom, which used them to weave complex patterns into fabric. Different sets of cards could instruct the engine to perform different tasks. It could add, subtract, multiply, and divide. It could even make decisions based on the results of its calculations, a concept we know today as conditional branching. This was programming a full century before the first electronic computers. To help him, Babbage collaborated with Ada Lovelace, a gifted mathematician and the daughter of the poet Lord Byron. She saw the true potential of the analytical engine, realizing it could manipulate not just numbers, but any symbol like musical notes or letters. She wrote what is now recognized as the world's first computer program, an algorithm for the analytical engine to calculate a sequence of numbers. Because of this, she is often celebrated as the first computer programmer. So, with such brilliant designs for both the difference engine and the world-changing analytical engine, why were they never built during Babbage's lifetime? The reasons are complex. Firstly, the technology of the day was barely up to the task. Manufacturing thousands of identical high-precision gears and levers was an immense challenge. It was the absolute cutting edge of Victorian engineering. Secondly, the costs were astronomical. Babbage poured his own fortune and a significant amount of government funding into the project, but it became a financial black hole. His constant desire for perfection led to endless redesigns, causing frustration among his sponsors. Eventually, the government, after a decade of funding with no finished machine to show for it, pulled the plug. Babbage became a somewhat embittered figure, a man who felt his own country had failed to grasp the importance of his work. He spent the rest of his life refining the plans for his analytical engine, creating detailed drawings that would lie dormant for a century. For decades, Babbage was remembered mostly as an eccentric failure, but history has a way of catching up with genius. As the 20th century dawned and the age of electronic computing began, pioneers like Alan Turing and Howard Aiken independently rediscovered the same core principles that Babbage had laid out 100 years earlier. When they looked back at his work, they were stunned. The logical structure of their early electronic computers, like the Harvard Mark I, bore an uncanny resemblance to Babbage's mechanical analytical engine. The store, the mill, the input and output it was all there in his 19th century drawings. He had seen the future with perfect clarity. To prove that Babbage's vision was not just a fantasy, the London Science Museum undertook an incredible project in 1985, using only his original plans and the manufacturing techniques available in the 19th century. They decided to build difference engine number 2. It was a massive undertaking. After years of meticulous work, the machine was completed in 1991 for the 200th anniversary of Babbage's birth. The moment of truth arrived. They turned the crank, and the thousands of gears, levers, and wheels sprang to life. It worked flawlessly. It calculated 231 decimal places, an astonishing feat of mechanical engineering. The printer, completed later, also worked perfectly, producing error-free tables just as Babbage had intended. The project proved that Babbage wasn't a failure. He was simply a man born a century too soon. His designs were sound. It was the world that wasn't ready for him. Today, every time you use your smartphone, browse the web, or even watch this video, you are interacting with the legacy of Charles Babbage. The fundamental logic of the device in your hand, the separation of processing and memory, the ability to be programmed for countless tasks traces a direct line back to a cluttered London workshop filled with brass gears and the dreams of a Victorian visionary. He may not have built his computer, but he gave us the blueprint. He is, without a doubt, the father of the computer. His story is a powerful reminder that sometimes the greatest ideas have to wait for the world to catch up. Thank you so much for joining me on this journey back in time. If you found this story as fascinating as I do, please hit that like button and subscribe for more stories about the incredible history of science and technology. Let me know in the comments what other historical inventions you'd like to explore. See you in the next video.